In this video on this 2 1/4 5 bearing engine, what I'm going to be doing is fitting the seal in the front cover. Kind of easy, isn't it? But not. There's more to it than meets the eye, because the original seal was held in by a metal shield, and this was missing. This sort of goes on here like this, look. I don't know if it does anything, but it provides a shoulder for the seal. But unfortunately there's no shoulder on the inside, so there's nothing to stop the seal popping inside. But they said it's what do they call it? Mud excluder. Well, I don't know about that. But anyway, what the problem is, that this seal has been replaced before, and what you had to do was drill out the rivets that was holding that shield in here. It was held in by some, like, not pop rivets, but hammer over rivets, if you mean, from both sides. Well, the problem is there's a potential leak around where these screws are, because somebody's drilled these out far bigger than the holes that were actually for the rivets, and they've tried to put self-tapping screws. Namely, this one here is really big. But anyway, there's the seal, and you have to buy it separately for some bizarre reason. I don't know why. It's nothing really fancy, it's just a rubber seal. But what I'm going to do is I'm going to go across to my press and press this in and press it flush. Now, I wouldn't really recommend it doing it with a hammer, but get it as square as possible and flush this surface here, flush with the top. Alright, so I'm going to press that in, then we'll come back. So there's the seal pressed into place. I used a disc like this, which is actually bigger than the outside diameter of the seal, so it fits flush, and it looks really nice now, doesn't it? It looks really good. So we'll put that back in the box, and now we're going to fit this sort of alleged dust shield. Now this in itself proves a problem because of the screw holes. So what I'm going to do, hopefully, is use some pop rivets to hold it in. It's not a structural part or anything like that, but I'm thinking that some of these holes are quite big, so I might have to put a different pop rivet in there. But for some of the holes, it's not a bad size, if you see what I mean. You know, it's like, I think in the original rivet holes it would have held in really well, but some of them are not quite right, see? So what I'm going to do is I'm going to drill through here the same size as this, but in here I might have to put some different rivets in. I don't want to drill these all out too big, like to, what's my next size? I think it's 3/16. These are, you know, these are a little bit too big, and these are 1/8. So are they going to go through here? Yes, you see, they go through there. So I think what I'll do, because like I say, I'm not really sure what I'm doing here, I'm going to put a bit of sealer on here, some of this Loctite 5980 sealer that we use for sumps, or oil pans, or whatever you want to call them. I'm just going to take I put a little bit of oil in the end of here, just to stop it drying out. So I'll put a little bit of sealer in, I'll smear it round with my finger, like that. This is principally to try and seal up the holes. So when we put a pop rivet in, it's going to try and seal it up. So what we'll do, we'll put the ring on, and we'll try and locate some original, not that one, these ones here. We'll try and locate the original holes, like that, and we'll put quite a few in that we can get in, and then we might have to just do a different size seal, different size pop rivet. It's really frustrating, but we'll get there. That's if the holes all line up. Some of them are a nice tight fit with a 1/8 rivet in. But of course when the front crank seal leaks like this, people are tempted just to take the front pulley off and try and get it off as best they can, and put like self-tapping screws in, which is probably okay, but again you've got potential oil leaks through the threads. We don't want that. Oh, there's one there, look, you see that one goes in nice and tight. That's nice. Well, I think we might get away with everything except this bottom one. Ooh. So we'll get our pop rivet gun. We'll put it on. Now I'm only going to nip them down a little bit at a time. There you go. That's one. Let's go back to this one. You want it to look neat as well, you know what I mean? Oh, that looks neat. Now, for this bottom one, can we get away with an 1/8 one? Because it is a bigger hole. I'll tell you what, let's have a go, see if it'll pull in. I don't know, if it does, job done. Job done. So, there you can make a very neat job of a seal, and if somebody wants to drill it out again, well, no problem to replace the seal. But it's a really crazy idea. It just didn't make any sense, because obviously you've got to drill the rivets out, and then to get the rivets out, if you just want to replace the seal in situ, well, you've got to knock out the rivets, which is obviously going to end up in the sump. But I'm quite pleased with that. That's gone really, really well. Look at that. Isn't it beautiful? I don't think he'll even bother putting up bloody car. The next thing we're going to do is have a look at the oil pump. I'll turn this off. The oil pump on the 2.25 was the same on the series. It went right up to the 200 TDI. It was a good little design. When it went on to 300 TDI, they went on to a sort of like a concentric pump that was on the end of the crankshaft. And the problem with that, as many of you know, is that once it goes dry, it's very difficult to suck oil back up into the pump to pressurise the system. Whereas these little guys here sit in the sump, so there's no reason why oil can't get into it, as long as you put oil in it, naturally. Now, I don't know if you can see here, I've already stripped this one down once because I was missing some parts, but I put some little pop marks on here, like with a punch, to show that where the gears went in sync with each other, because sometimes gears all wear together, and if you put them in a different place, sometimes it's not quite right. But I've got the spec sheet here, printed this one out, and it says the clearance of the gears should be, I'm going to do it with thousandths of an inch because it's easier, 3 thousandths to almost 7 thousandths of an inch. So I've got a 3 thousandths gauge here. I'm trying it in the side, and it's a nice tight fit. Alright, so we know that the casing isn't worn, and the gears are nice. You know, they're really nice, and in fact this one is just, say, look at that, 3 thousandths of an inch, nice tight fit. I don't think there's any problem with this. In the book also they suggest you put a straight edge across here and measure the height. However, with a bit of experience and things like this, you can actually run your fingers across the top, and if it feels flush, it's good. If you ever do need to replace the gears through damage, if it sucked up any debris or anything like this, you must also always replace these as a matching pair. It comes as a matching pair. Cast iron outside, good old cast iron, but an aluminium pump gear here and a steel one here. Now, as you can probably see, I've already sort of put Vaseline in here. just to help the lubrication when it goes into the car. But it's really simple. I mean, your pressure relief valve goes in here, and this is what we're going to put in a minute. And this is your intake. Now the pressure relief valve keeps a constant pressure of, let me read the book, it says between 25 and 55 psi, or what's that, 1.76 to 3.86 kilograms force per centimetre squared. PSI, a lot easier, isn't it? So what happens with a relief valve is if the system gets overpressurized, for example, if you've got really nice tight bearings and things like this, the spring here will overcome pressure and dump it back into the system, dump it back into the sump, or recirculate it back in. Yeah, no, I see how it goes. So let's have a show. Let's show you how it works. This is easy. So there's the ball. The ball is a seat. This is a piston, and this sits in here. So if the oil pressure is too much here, this pushes back, and then oil is allowed to go back up this tube here into the gears. It recirculates itself, so it doesn't overpressurize the system. And a lot of people like to have, oh, I've got to have high oil pressure and high oil pressure, you know, that's the most important thing. Well, not necessarily. You know, sometimes you need volume rather than pressure. And that's the old engines did. The Rover V8s needed volume, not pressure. So let's have a look at this, what we can put back together, because I have here some brand new springs. Unfortunately, you had to buy them in packs of 10. I only want one. But there's the old spring here, and there's the new spring. Is there any difference? Hardly any at all. Negligible. We could use this one again, but since I've gone to the trouble of buying them, I'm going to put a new one in. So let's do that. I've already coated this with Vaseline. We push the ball in, and the piston, and the spring. Now again, I've already sort of pre-done this one in the previous video and realised I was missing a washer, a lock-in washer and things like this. I've annealed this copper washer because it's kind of special. I heated it up to cherry red on top of the vise and let it cool on its own, so it's nice and soft. We slip it over here so we can use this one again. I'd rather use old copper. I must admit, I'd rather use old good copper washers than these Chinese ones that are steel. So we're going to put this onto here, screw it in, and we're going to tighten it down. I'm going to put this in the vise, and we can tighten it down. So that's your pressure relief sorted. So the next thing we're going to do is assemble the filter. Now we've got a new lock washer. Unfortunately, again, I had to buy them in a packet of 5 because I only wanted one, but these are trade prices. But if you get things off Paddocks LR Direct, they'll just sell you one. We're going to put the lock washer over the nut, thus. Now the original oil O-ring, when I can find it, was here. That's the original seal, and you can see how much it's got compressed. This is what they supply now, just a regular O-ring. So we're going to pop that into there, and it is a nice fit. And then we're going to put this with the lock washer onto here, and you can understand now why I didn't put the bolts in the top of this yet, because this goes into here. Oh, wait a minute. It'll be fiddly. It is a big nut. You might not be able to get a spanner onto it. You might have to use a pair of adjustables. Now you see here, there is a little place here to put the lock washer. You see those little two cast lugs there? You put one. You're going to knock one piece down that way, and one piece over the top of the lock washer. See, it's a very good piece of engineering. And we're going to, before we tighten anything up, always put the bolts in right, always put the bolts in before you tighten anything up, you know, just get them all lined up, because if we would tighten this up here, we might not be able to get the bolts lined up. So now's the time to put these bolts in, if they will. A bit awkward. There we go. Just 4 bolts. Now you can see why, in a way, they did away with this pump, because look at the machining and the castings on this just to make a pump, where you made 2 concentric rings in the timing cover so much easier. But again, these, in my opinion, were a lot better pump. Now we're going to torque these down later, but for now we're just going to use a little gun and we're going to whiz them down just enough, and then we'll torque them down. Doesn't need much, and remember they've got spring washers on them. And then somehow we're going to tighten this nut down here. It's tight, you can feel it's tightening against that O-ring. So I'm going to get probably an adjustable and nip that down. I don't think I've got a spanner that will actually fit in there. I've got a spanner that's big enough to go in there, but I won't be able to get its head in, so that's going to be a problem. Let me see if I can tighten it down. It's going to be tricky. What I've done is I've pre-bent over the lug here to fit in those 2 grooves, so I can tighten this down. And remember, you're tightening it against an O-ring, so it's going to seal. But what we want is that tab washer there against a flat. So I think the next one, if I can get it there, oh, maybe I can get it a bit more. Ooh. Maybe. That's a bit tricky, isn't it? Because it's halfway on the flat. Let me see if I can put this in the vise and tighten it down a bit further. And the answer was quite difficult. I actually just had to tap it with a chisel just to knock it around that little bit. But you can see there, look, you see where it's gone between these 2 lugs? That's nice and tight. The thing is, you don't want this shaking loose and letting air or whatever get into it, so it won't let oil in past the filter, if you see what I mean. You know, if this was all loose, you could bring dirt and debris past the filter. We don't want that. So that really is nice and ready to go. Where's the shaft gone? Now, is that the right way? Is that the right way? There we go. And look. Lovely. Nice and tight. You know, it feels right. If it feels right, it's going to be right. You know what I mean? So that's the oil pump done. Put this in the bag. Keep all the dirt out. And we're good to go, and that's another assembly done. All I've got to do now is wait for the other parts to come. I've got to put all these bits and pieces into duckets and things like this but you know, like, I don't know. I mean, look at somebody who's put this, somebody's had this in bits before. Look at the state of that one. You see, you can't use them again. You can't use tab washers again, because if you bend it back it could break, and that's no good. But again, so I've got 10 O-rings in there, 9 O-rings left. I don't know what I'm going to do. Anyway, that's good. That's the oil pump done. We'll do something later. I mean, I'm desperate to get the block back so we can put all this back together. But if we do all the little ancillaries, once we start to put it back together, it's going to be a dream. We don't have to stop, start. I've got some other bits over there, but they're already done. Like the timing system, you know, the tensioner. I might as well add it onto this video because this is kind of quick. Let's have a look. This is a really good idea. I've already stripped and cleaned it in the fine sand, put it through the ultrasound, got all the muck out of it, and it's come out really well, and you can see how fine the sand was because it didn't even take the copper off this finish here. It's a good piece of engineering, must have cost a fortune to make, but how it works is that oil goes through this hole here and pushes this piston, so this gear is in constant tension with the timing chain. However, if you're thinking, oh, if you turn the engine off you're going to lose oil pressure, well, not so, because if you look at this side here, there's a sort of a toothed arrangement here that's on a spring. Now I've put a I put a tie wrap around it to hold it together so I can put it in the car, or in the engine. But the idea is that oil pressure can push it this way, but the ratchet's holding it back from going this way. So when you turn your engine off, you've got no oil pressure. You don't have a rattly chain. It's a really, really good idea. It must have cost a fortune to make. But that's it. There's nothing else to do on that one. It's a lovely piece of engineering. It's a lovely piece of kit. And when we get it on with the new chain, we checked all the teeth here. That's lovely. They're all nice, you know. Yeah. So I thought I'd show you that. It's done. It's in the bag. You know, ready to fit. So I hope you like that. That was just a few little bits and pieces. A few ancillaries. We're getting there. Just all we have to do is wait for Claude to get his ass into gear and bore the block. See you later.